After dot product, we will discuss cross product of two vectors. Cross product is also called vector product because the resultant is a vector. So A cross B is written as A into B into sine theta into n cap. Here this A is A and B, both are magnitude of vector A and B. Theta is angle between vector A and vector B. N cap is a unit vector. N cap here is a unit vector perpendicular to A and B both, and its direction is given by right hand screw rule, which we will discuss here. Suppose this is vector A, this is vector B. So if I want to write A cross B, A cross B means I will rotate this A towards this vector B through a smaller angle, and the thumb will point in the direction. If the finger points in the direction of rotation, then the thumb will point in the direction of this n cap. So this is the direction of n cap. Again I am saying A cross B means we will rotate this vector A towards this vector B and hold the finger like this. If the direction of rotation is represented by the direction of rotation of this finger, then the thumb will point in the direction of this n cap. This law is also called right hand screw rule. See the movement of screw. If we rotate this screw in the direction of the rotation of this finger, then the thumb will point in the direction of this vector n cap. See, this is vector A, this is vector B. A cross B will give me vector C. So I will rotate this vector A towards this vector B. If this is B here, I will rotate it in this direction. If B is here, I will rotate it in this direction. If B is here, I will rotate in this direction. Then this is the vector C, which is also the direction of n cap. So this is called right hand screw rule. See the rotation of finger will points in this figure. I will rotate this A towards B. So A cross B here is A cross B. I will rotate this A towards B. Then the thumb will go downward, and that is the direction of n cap. A cross B means we have to rotate A in this direction. In that situation, the thumb will point upward, and this is the direction of n cap. Here are some standard vector cross product. So I cross I. As we know, A cross B means AB sine theta is AB sine theta into n cap. So I cross I. In place of A it is I. In place of B it is I. So we know the angle between I and I is 0. So I cross I is 1 into 1. Mod of I is 1. Mod of I is again 1. And the sign 0 is 0. So it is a null vector. Similarly, J cross J is also 0. K cross K is also 0. Now I cross J. I cross J cap. So I cap cross J cap, mod of I cap is 1, mod of J cap is also 1, and the angle between I and J is 90 degrees, so it is also sin 90 is 1, and the direction if we rotate I cap towards this J cap, then the thumb will point in the direction of K cap, so it is actually K cap. So I cap cross J cap is K cap. Similarly, J cross K. J cross K means we have to rotate J towards K. So it is in the direction of I cap. So it is I cap. K cross I. If you see K cross I, if we rotate K towards I, it is J cap. Similarly, J cross I is minus K cap. K cross J is minus I cap. And I cross K is minus J cap. Now the question is, find the cross product of A 2I cap plus 3J cap and B. So suppose this is vector C, which is equal to vector A cross, this is vector A cross vector b. So this is equal to 2 I cap plus 3 j cap cross b means 2 I cap plus j cap. This is equal to 2 I cap cross 2 I cap plus j plus 3 j cap cross 2 I cap plus j cap. This is equal to 2 into 2, that is 4. I cap cross I cap means 0 plus 2 into 1, that is 2. I cross j, as we know I cross j is k cap. I cross j is k cap, so it is k cap plus 3 into 2, that is 6, and j cross I, we know j cross I is minus k cap, so I will put here it is minus k cap plus 3 into 1, that is 3, j cross j, that is 0, so it comes out to be minus 4 k cap. This is the final answer. This question can again be solved by another method, that is called determinant method. So I will write it as this: A cross B means we have to draw a determinant, substitute here I, j, k, put the coefficient of I cap here, put the coefficient of j cap here, k cap, since k cap is not here, so I will substitute here 0. Similarly, second position, this is the first position, this is the second position. In second position the vector b is there, so I will substitute the coefficient of I cap of vector here, it is 2. J cap coefficient is 1, I will substitute here 1, and k cap is not there, so it is 0. So A cross B, I will substitute the coefficient of A first and then coefficient of B second. Now we will substitute a sign here, plus, minus, plus. Now this can be written as, we will take I cap. Now if I take I cap, I will leave this row and this column and multiply this 3 into 0, that is 0, minus this one, 1 into 0, that is 0. Now this sign is minus, so I will write here minus. This is j cap, so this is j cap. Now if I take this one, I will leave this row and this column and take the remaining one, 2 into 0, so it is 2 into 0 minus 2 into 0, it is 2 into 0 plus, now it is plus, so it is plus k cap. Leaving this row and this column, we get 2 into 1, it is 2 into 1 minus 3 into 2, that is 6. So this comes out to be minus 4 k cap. This is the answer. This is determinant method which we will use. Now find A cross B if A is 2 I cap plus 2 j cap plus k cap and B is 3 I cap minus 2 j cap plus 3 k cap. So A cross B, I will make a determinant here. A cross B means the first position is A and in second position it is B, so I will make a determinant, substitute here I cap, j cap, k cap. First I will take the coefficient of A, it is 2, it is 2, it is 1. Now after that B, the coefficient of B here is 3, minus 2 and 3. Now first I will take I cap, substituting this is A cross B is equal to, this is positive, this is negative, this is positive. I cap, I will leave this row and this column, so it is 2 into 3, that is 6, minus 1 into minus 2 is minus 2, so it become plus 2, plus, now it is minus j, so minus j cap, leaving this row and column, it is 2 into 3, that is 6, minus 3 into 1, that is 3, I will substitute here a positive sign plus k cap into 2 into minus 2 is minus 4 minus 3 into 2, that is 6. So A cross B is equal to 8 I cap minus 3 j cap, and it is minus 10 k cap. So this is the value of A cross B here. Next question is, now the property, if A cross B is 0, then the two non-zero vector must be parallel or anti-parallel. As we know, A cross B is 0, and if A and B are not 0, then they are always, the angle between them is either 0 or 180, because we know sine 0 is 0 and sine 180 is also 0. The area of triangle formed by vector A and vector B is half of mod of A cross B, because as we know the area of triangle is given by, this is vector A, this is vector B. The triangle formed by these two vector, this angle is theta. The triangle formed by these two vector is, its area is given by half into A into B into sine theta. So the area of triangle is also equal to 1 by 2 mod of A cross B. For any two vector, there is a question, for any two vector A and B, if A dot B is equal to mod of A cross B, then find the magnitude of C, which is equal to A plus B. We know it is given that A dot B means it is A B cos theta, and mod of A cross B is A B sin theta, because mod of n cap is 1. So it implies that both are equal, means tan theta is equal to 1. It means theta is 45 degree, means the angle between the two vector is 45 degree. Now C is equal to A plus B. So mod of C is mod of A plus B, which is equal to root over A square plus B square plus twice AB cos theta. Now we know cos theta is 45 degree, theta is 45 degree, so cos 45 is 1 by root 2, so it comes out to be A square plus B square plus root 2 AB. That's all. This is the answer. The question is, the magnitude of vector product of two vectors is root 3. So mod of A cross B is equal to root 3 times A dot B. It means A cross B means A B sin theta is equal to root 3 times A dot B means A B cos theta. So from here we get tan theta, that is equal to root 3, or theta is equal to 60 degree, or it is also equal to pi by 3. So C is the right answer.